On the first day of March, 1982, a photograph slowly materialized on a screen somewhere deep within the Soviet Union. It was an image from the surface of another world, a landscape of grey rocks and dark soil stretching out to a flat horizon under an alien sky. This wasn't just any picture, it came from a place where, until just hours before, nothing crafted by human hands had ever lasted long enough to snap a photo. The machine sending this image back was already succumbing to the brutal conditions, its systems failing under unbearable heat. For 3 decades, almost nobody gave this image a careful look. But then, one man did. Leonid Ksanfomaliti, a senior Soviet scientist and one of the architects behind these very missions, did something no one else had bothered to do. He laid the original frames side by side, in order, and asked a simple question. Did anything move? Off to one side of the lander, in the soil, a shape appeared. At first, it was not there. Then a shallow groove showed up in the dirt. Next, a partial structure emerged. About an hour and a half after landing, the shape was fully visible, roughly the size of a human hand. Ksanfomaliti kept watching. A few frames later, the shape disappeared. He double-checked everything. The lander was intact. Nothing had fallen off. Whatever this was, it emerged, changed, and vanished on a planet so hot it could melt lead. He published his findings. The response was swift and harsh. In no uncertain terms, he was told there was nothing there worth seeing. The photographs were shoved back into the archives. The question went silent, but it never truly disappeared. The more anyone examined these Soviet images and the planet they came from, the harder it became to dismiss that something might have indeed been there. That planet was Venus. By every measure, Venus is the most hostile environment human machines have ever touched and survived to report from. Start with the air. The atmosphere is nearly 100% carbon dioxide, about 96 parts out of every 100, with just a pinch of nitrogen and barely anything else. It's the densest atmosphere of any rocky planet in our solar system. Imagine standing on the surface beneath all that air. The pressure there is about 90 times what you feel at sea level on Earth. To find a comparable squeeze here, you'd have to dive nearly a kilometre deep into the ocean, where sunlight fades and the water presses in like a solid wall. But on Venus, it's not water, it's air crushing down on solid rock. Then there's the heat. The average temperature on Venus clocks in at around 460 degrees Celsius, hot enough to melt lead, and it barely changes. Day or night, equator or poles, the whole planet bakes in a relentless furnace. Above all this hangs a permanent veil of thick, opaque clouds, not of water, but droplets of sulfuric acid. These clouds are so dense that from space, in normal visible light, the surface is completely hidden. Venus keeps its secrets well. This was the challenge the Soviet Union faced, to land a machine on Venus that could survive falling through clouds of acid, endure crushing pressure, and withstand heat that would destroy nearly any known material, all long enough to conduct science and send data back home. It sounded impossible, yet, time and again, they pulled it off. Starting in 1972 with a probe called Venera 8, the Soviets landed on Venus 9 separate times. Not just flybys or orbits, but actual landings. Most of these landers stayed alive and transmitting as long as their orbiters were overhead to relay signals. In many cases, the ground machines outlived the communication windows they were designed for, lasting longer than expected. And it didn't stop there. In 1985, the Soviets sent 2 probes that released balloons into the Venusian atmosphere on the night side, letting them drift through the clouds for nearly 2 days, measuring the alien air as they floated downward. Here's an incredible fact. Those Soviet landings remain the only direct on-the-ground data we have from Venus. Every map made from orbit, every model of the surface, every observation from Earth telescopes, all of it still relies on the data those missions collected in the 1970s and early 80s. We haven't been back since. That's the weight these old photographs carry. They're not just relics. For half a century, they've been the closest thing humanity has had to standing on Venus. Now, let's focus on the man at the heart of this story, Leonid Ksanfomaliti. By the time he made headlines for controversial reasons, he was already one of Russia's most respected planetary scientists. He graduated from Leningrad Technical University in the mid-50s, worked at an observatory, and by 1968 joined the Space Research Institute. There, he headed a lab studying the light and heat planets emit. Ksanfomaliti was no fringe figure. He was a senior statesman in his field, a scientist, engineer, and communicator who spent decades making space science accessible to the public. His instruments flew on mission after mission. He designed sensors for Soviet Mars probes and worked on analyzing Venus's clouds during earlier Venera flights. He also developed a set of instruments called Groza, which flew on several Venera landers. That detail matters because those Groza sensors were the first ever to detect intense lightning storms in Venus's atmosphere. Pause and think about that. Long before controversy, this was a man who pointed instruments at Venus and discovered something real, that the planet's acid clouds crackle with lightning. So when decades later Ksanfomaliti revisited the old Venera photos and declared he saw movement in them, the scientific community couldn't just dismiss him as a crank. He had earned the right to be taken seriously, and that's what made what came next so difficult. To understand what he saw, we need to understand the machine that took the pictures. Venera 13, built alongside its twin, Venera 14, to exploit a launch window in 1981. The probes left Earth just 5 days apart. Venera 13 launched on October 30th, 1981, then spent about 4 months crossing the space between planets. On March 1st, 1982, the descent module separated from the main spacecraft and began its plunge toward Venus's surface. That fall was no simple drop. The lander entered the thick atmosphere and deployed a parachute. But Venus's dense air slows falling objects so effectively that at around 50 kilometers above the surface, the parachute was cut loose. From there, the lander used the heavy atmosphere itself to brake for the rest of the descent. It touched down at about 7 to 8 meters per second, roughly the speed of a fast fall. It landed just east of an elevated region called Phoebe Regio, a terrain of bedrock surrounded by dark, fine soil. Then it started its work. Here's the most remarkable fact about Venera 13. It was built to last about 32 minutes on Venus's surface. It survived at least 127 minutes. Think about that. In a place hot enough to melt metal under pressure that would crush a submarine, a sealed Soviet machine kept its instruments alive and sent data for more than 4 times longer than expected. Every extra minute was unplanned, a bonus. How did it survive? The lander was a hermetically sealed pressure vessel, filled with blocks of lithium nitrate, a salt-like material chosen because it absorbs huge amounts of heat as it melts. As Venus's heat poured in, the lithium nitrate soaked it up, keeping the electronics cool enough to function for over 2 hours. While alive, the lander drilled into the surface, pulling samples into a sealed, controlled chamber to analyze. It identified the soil as a dark volcanic rock, similar to basalt. It measured atmosphere, light, soil, even recorded sound. Yes, sound. Venera 13 captured the first audio ever recorded on another planet. It picked up Venusian wind, the thud of landing, the small pop of lens caps blowing off right after touchdown, and the grinding of its drill biting into the surface. The lander had 2 cameras looking out in different directions, each sealed behind quartz windows covered by protective lens caps designed to pop off after landing. For Venera 13, only 1 cap came off cleanly. Remember that detail, a single lens cap lying somewhere on Venus's soil. It's going to matter. As the cameras swung across the landscape, they built panoramas line by line, sweep by sweep. For 30 years, people mostly looked at a single composite panorama from each landing site, an illusion crafted by stitching together the best parts of multiple scans. Ksanfomaliti noticed something no one else had. The individual frames, the raw scans, had never been laid side by side and compared. So he did that. He lined up the separate frames from Venera 13 and asked, frame by frame, does anything change? What he found is the heart of this story. Ksanfomaliti reported several objects appearing in the images, ranging from about 10 centimeters up to 50 centimeters in size. These objects had what he called unusual shapes, and more than that, they didn't stay put. They appeared, disappeared, and changed form between frames. He gave these objects names. One was the disk, another the black rag, and the one that made headlines, the scorpion. Let's focus on the scorpion because it's the clearest example. According to Ksanfomaliti, this object appeared on the camera looking out one side of the lander around the 90th minute of the mission. By then, the lander had been on the surface working for over an hour and a half. His first guess was that it might be a piece of the lander that had broken off, but he checked the records. The lander kept functioning for a full hour after the scorpion appeared. If a piece had broken off, the lander should have failed quickly under the heat rushing in through the damage. It didn't. It stayed healthy for another 60 minutes. So Ksanfomaliti went back and looked at earlier frames of that exact spot. He described a sequence. At 7 minutes in, a shallow groove about 10 centimeters long appeared in the soil, likely from the landing stirring up dirt. By 20 minutes, the groove's edges had risen and grown to about 15 centimeters. At 59 minutes, a structured shape began to take form inside the groove. By 93 minutes, the full object had apparently recovered from the soil covering it, soil estimated to be only about 1 or 2 centimeters deep. The whole emergence, from the first groove to the full shape, took roughly 90 minutes. Then, by the 119th minute, the object was gone. Now, here's the key point. Ksanfomaliti's interpretation wasn't a direct measurement, but a hypothesis. He proposed that the violent landing, explosive bolts firing, drill grinding, soil thrown aside, might have buried something alive. He speculated that on one side of the lander, any life could have moved away from danger, while on the other side, some creature or object was trapped and covered by the ejected soil. The slow reappearance of the scorpion was, in his view, something digging itself out, limited in strength, but determined. This is extraordinary. A serious scientist suggesting that a structured object emerged from Venusian soil over an hour and a half, then vanished on a planet hot enough to melt lead. Ksanfomaliti was careful to add that no retouching or adding of details had been done to the images. That one sentence sparked the controversy. Before diving into the backlash, it's crucial to understand the images themselves, because almost everything in this debate hinges on one question. Are these changes real, or just tricks of light, dust, or camera artifacts? The entire debate about life, or anything unusual, on Venus boils down to one tricky question. Are the changes seen in the images real, or are they just illusions created by light, dust, or glitches in the cameras? Peeling back the layers of this question reveals just how difficult it is to actually see anything on Venus's surface. The planet is cloaked in thick, acidic clouds that block and scatter sunlight. What little light does make it through is faint, scattered, and constantly shifting because the clouds above are always moving. For example, during the Venera 13 mission, 2 photos taken just an hour apart showed noticeable differences in lighting, sometimes sharper, sometimes softer, because the cloud cover overhead was drifting, casting moving shadows and patches of brightness on the ground. So right from the start, the lighting conditions are unstable, making it hard to get a consistent view. Then there's the surface itself. Venera 13 didn't land gently, it hit hard enough to stir up the soil and dust around it. This kicked up particles that settled on the lander's flat surfaces and on the ground nearby. Over its short lifespan, the lander's own wind blew some of that dust away, changing the scene visibly between photos taken just minutes apart. For instance, images taken an hour apart showed soil gradually disappearing from the lander's landing ring, not because anything alive was moving, but because the disturbed dust was settling and then being blown off. so the surface changes naturally over time, adding another layer of complexity to interpreting the images. And here's where things get even trickier: how the images were transmitted back to Earth. The pictures were sent from the lander to an orbiter, then relayed to Earth using two different methods of encoding the radio signal. Each method introduced its own type of noise or distortion into the final images. When two versions of the same Venera 13 panorama were compared pixel by pixel, they weren't identical. Most details lined up, but scattered throughout were differences caused by transmission errors. Bits of data missing here, slight shifts in color values there, and weird patterns of noise. Almost all of these differences came from the signal noise, not from anything on Venus itself. This is where the story's conclusion quietly starts to appear. All these factors, the crushing pressure, the intense heat, the disturbed soil, the shifting lighting, and the noisy transmissions, relate to the surface, the harsh environment where Venera 13 lasted just over 2 hours. Yet, intriguingly, the only Venus activity confirmed beyond doubt, lightning, doesn't happen on the surface. It crackles high up in the clouds, about 30 miles above the ground, where temperatures drop to a comparatively mild warmth, something like a pleasant afternoon on Earth. This contrast between the hostile surface and the gentler cloud layers is worth remembering. Back on the surface, the real debate revolves around what exactly is visible in the images. When all these shifting lights, dusty disturbances, wind effects, and transmission noise are combined, it becomes dangerous to overinterpret slight changes in blurry shapes from one photo to the next. Critics argue that this is exactly where the supposed scorpion lives, not on Venus, but in the noise and artifacts of the images. The researcher who first described the scorpion, Leonid Ksanfomaliti, also pointed out two other mysterious objects in the photos, and their behavior offers clues on how to interpret the whole scene. The second object, called the black rag, appeared as a vertical black shape about 2.5 inches tall, wrapped around one of the lander's soil testing instruments shortly after landing. But within half an hour, it vanished completely. Unlike the scorpion, which seemed to be out in the open, the black rag clung to the lander's equipment and disappeared during the period when dust was still settling and being blown away. This timing suggests it was likely just dust or debris disturbed by the lander's touchdown. The third object, known as the disk, is where the debate gets even more complicated. This was a round, half-visible shape about a foot across, cut off by the edge of the photo. Cheek claimed it shifted position slightly, changed shape, and even seemed to break apart in some frames before being replaced by a different bright, angular object that resembled folded chevrons. But engineers familiar with the mission offered a simpler explanation. Venera 13 had two lens caps that were designed to pop off after landing and land on the surface. The disk was likely one of these caps in one position, and in another photo, the other cap, creating the illusion of a moving object. Skeptics see a consistent pattern: no life, just hardware parts, dust, shifting light, and noise creating illusions. Then there's a critical detail that undercut Cheek's claims. In his defense of the images, he insisted no retouching or editing had been done, yet he also admitted to processing the images. This included filling in missing parts with data from other photos, adjusting contrast and brightness, and applying blur and sharpen tools from basic image editing software. These aren't minor tweaks. Sharpening in particular can be dangerous because it can create false edges and outlines in noisy images, making rocks appear to have distinct shapes that aren't really there. So, the man who insisted the images were untouched actually admitted to brightening, sharpening, and patching them. When a space science writer examined these images years later, her conclusion was clear. With so much noise and image manipulation, there was no point in obsessively analysing tiny shapes to decide if they moved or if they were alive. To her, there was simply nothing there. The sensational headline, "Life Spotted on Venus," from a Russian news agency caught public attention, but scientists quickly pushed back. Journals published rebuttals, and popular science outlets debunked the claim. Meanwhile, Chick continued to publish further articles describing more shapes he believed were living creatures around the landing site. To many in the scientific community, this looked like a respected scientist had lost his grip on reality, but the story didn't end there. Years later, researchers returned to the question using modern tools that Chick never had. This was the first time the debate moved beyond just two sets of human eyes arguing over blurry photos. The object once called the Scorpion was renamed the Target to remove bias, and it underwent three types of analysis. First, detailed image processing compared the object's surface to the soil around it, tracing fine details and edges. Second, machine learning algorithms, similar to those used for facial recognition, were trained to compare tiny patches of the object against random patches of soil to see if the object stood out. Third, fractal analysis measured the complexity and branching patterns of the object compared to the surrounding dirt. The results weren't clear-cut. On one hand, the analyses confirmed the object was distinct from the soil. It appeared sharper and more focused than the surrounding ground, with fractal measurements showing it was slightly more complex and more uniform than random soil patches. The complexity increased when the object appeared and decreased when it vanished. This suggested that something measurable really did change in that spot, matching Chick's descriptions. This ruled out simple explanations like someone pasting a fake object onto the image or the wind blowing debris into view. But on the other hand, the object's structure closely resembled the soil's. Its tube-like branching patterns looked continuous with the ground, as if it was made of the same material and partially merged into the soil. Machine learning found only faint differences, and visually, the object blended in with its surroundings. In the end, the study carefully concluded that, on balance, the object was most likely lifeless. Its lifelike appearance was probably an artifact of repeated image processing. Sharpening a noisy patch of ground over and over can coax shapes that look like heads, bodies, and limbs out of random noise. Yet the conclusion wasn't absolute. The authors cautioned that we can't know for sure what life might look like on a planet so different from Earth. To assume Venus is lifeless just because it's hostile to us is a form of bias, what one scientist called terrestrial chauvinism. The odds strongly favor the Scorpion not being alive, but the door isn't completely shut. So, the Scorpion rests today as almost certainly a trick of dust, noise, and an old scientist's image sharpening tools, almost certainly, but not entirely. If this was the whole story, it would be a sad footnote. A brilliant scientist, long past his prime, seeing patterns where none exist. But the real question he was chasing never went away. It just shifted focus from the surface up into the atmosphere. In 2020, an international team of astronomers made a discovery about Venus that had nothing to do with old Soviet photos, but everything to do with that lingering question about life. They used telescopes to scan Venus, first a telescope in Hawaii in 2017, then a more sensitive array of antennas in Chile's high desert in 2019. Both detected a faint signal in the clouds, a gas called phosphine. The amount was tiny, just about 20 molecules per billion, barely a whisper, but phosphine is special. On Earth, it's considered a biosignature gas, one strongly linked to life on rocky planets. It's produced industrially or by microbes living without oxygen. Normal, lifeless chemistry produces almost none of it. That's why scientists have spent years studying phosphine as a possible marker of life on planets beyond our solar system. The team did their homework. They searched for every known non-living source of phosphine on Venus, sunlight-driven chemistry, minerals blasted up from the surface, volcanic activity, lightning, and found that all these natural sources combined could only account for a tiny fraction of what they measured. Their estimates said known processes fell short by about 10,000 times. So what could be creating this phosphine? There's one more clue that ties back to the Soviet missions. When the second of the two Vega balloon missions sent an instrument down through the lower clouds, it detected high levels of a phosphorus-bearing compound in the cloud particles. Phosphorus, the key ingredient in phosphine, was already present in the Venusian haze long before anyone was looking for it. This discovery doesn't prove life exists on Venus. It opens a new chapter in the search. Finding a biosignature gas is not the same as finding an organism. It means a mystery has been uncovered, a puzzle begging for answers. And then, the strangest part of the story appears, one that forces scientists to rethink everything about Venus. Imagine a place where the skies are cloaked in thick clouds, temperatures hover around what might feel almost comfortable, yet the air is soaked with nearly 90% sulfuric acid, an environment so hostile it would obliterate any life forms we know on Earth. This is Venus's upper atmosphere, roughly 50 kilometers above its surface, a realm so extreme that any potential life there would have to be utterly unlike anything we've ever encountered. The discovery of phosphine gas in those clouds shook the scientific community because phosphine on Earth is often linked to biological processes. If life exists on Venus, it would be surviving in one of the most punishing habitats imaginable. But as soon as the news broke, skepticism followed. True to the nature of rigorous science, other research teams dove into the data, re-examining every detail. Some suggested the phosphine signal was a product of data processing errors or statistical noise. Others proposed it might actually be a different gas masquerading as phosphine. Even the original team based in Chile found and acknowledged a flaw in their data, correcting it publicly so the entire scientific community could scrutinize their results. The debate is far from over. In fact, a subsequent observation campaign, employing alternative techniques, reported fresh evidence supporting the presence of phosphine. The controversy continues, embodying the very essence of scientific method: claim, doubt, retest, and either confirm or refute. This cycle isn't a sign of weakness, it's a testament to discipline. Looking back at similar extraordinary claims highlights why caution is vital. In 2014, a celebrated group of cosmologists announced they had detected ripples from the dawn of the universe. Headlines exploded worldwide, but later it became clear that what they'd detected was light scattered by dust in our own galaxy, not the echo of the Big Bang. The claim was withdrawn. On Mars, methane, a gas linked to life, was first detected in 2004, but follow-up missions delivered conflicting and inconclusive data, sparking ongoing debate. This is the normal journey for any groundbreaking discovery. The phosphine on Venus sits at the heart of this process now. When scientists recently sat down to review every possible source of this mysterious gas, they found themselves stuck with no satisfying explanation. They ruled out volcanic activity. There would need to be an unimaginable amount of volcanic resurfacing happening, far beyond what observations support. Simple atmospheric chemistry doesn't work either. Thermodynamics make it impossible. Chemical reactions within the sulfuric acid clouds are unlikely because concentrated acid breaks down phosphine rather than producing it. Lightning, which instruments first detected on Venus, tends to generate oxidized gases, not phosphine. Meteorite impacts are too infrequent and too minor to account for the quantities observed. The most plausible non-biological explanation left is some unusual sunlight-driven chemistry acting on dust particles high in the clouds. But even that remains unproven under Venus-like conditions in lab experiments. As for life, the reviewers didn't completely dismiss the idea, but they acknowledged why it seems improbable. On Earth, living organisms produce certain gases because it benefits their survival or reproduction. But on Venus, it's hard to understand why life would expend so much energy to create phosphine only to release it into the atmosphere. So, after the most thorough study yet, scientists arrive at a stark conclusion. No known process adequately explains the phosphine detected in Venus's clouds. This leaves two unsettling possibilities. Either our understanding of Venus's chemistry is seriously incomplete, or there's something there we haven't considered yet. The only way to find out for sure is to send instruments directly into those clouds and sample them firsthand. So far, humanity hasn't done that. The phosphine signal remains caught in limbo. neither confirmed nor dismissed, a puzzle suspended in data. Meanwhile, the story of Venus holds more mysteries. A man who dedicated his life to studying Venus designed instruments that revealed the planet's clouds are alive with lightning. Decades later, as he pored over the same grainy photographs others had ignored, he became convinced he spotted movement in the dirt, something alive or at least unusual. Skeptics dismissed him as lost to fantasy. Chances are they're right. The shapes he saw were probably tricks of light and shadow, noise spun into meaning by human imagination. Later missions with better technology gently confirmed the most likely explanation was nothing more than soil and random patterns. But even that careful version of the story leaves a door wide open. It doesn't give us answers, only questions. We still don't fully grasp Venus's chemistry. We have a gas in the clouds that, by every known rule, shouldn't be there in such amounts. The surface itself has been untouched by human probes for over 50 years, known only through machines that operated for mere minutes before succumbing to the planet's brutal heat. And we keep returning to the same question. Could anything possibly be alive in a world so harsh that every guess seems absurd? The honest stance of science isn't to leap to belief or dismissal. It's to accept uncertainty and hold it gently, to clearly separate what's known from what's suspected, and to keep the door open just as wide as the evidence demands, no more, no less. That balance is tougher than it sounds. Easy answers are tempting, life or no life, yes or no. But Venus has teased us for half a century with neither clear yes nor definitive no, and it may well keep doing so for decades more. Humanity built machines, sent them plunging through acid clouds, listened to the howling winds on a planet no human will ever set foot on, and captured brief images of its surface before the heat claimed every instrument. We trained the finest telescopes on that brilliant evening star and managed to tease out a faint, nearly impossible whisper of a molecule from the cosmic noise. Yet after all that effort, all those signals and arguments, here we stand on a quiet night, looking up at the second brightest point in the sky, still unable to say with certainty whether something, anything on Venus is looking back.